So in 1.2, we had spent some time talking about this idea of trade-offs. Just the idea that when dealing with scarcity, if you want to get one thing, you're going to have to give something else up. So when we consider those scarce resources, those productive resources we had talked about, and then the trade-offs as we make decisions about using those scarce resources, we kind of come to our first economic model that we can look at. And it's a model where we're able to look at our possible different options of using those resources. And then that model will also help inform us about the trade-offs that come from choosing one option versus another. So let's just start off with a really simple example. Let's say that when you get home after school that night, and after you get home and eat dinner and things like that, let's say you have 5 hours before you head to bed. And in those 5 hours, we're just going to be choosing from two different options of what you can do with your time. You can either study or you can spend your time hanging out with your friends. Now, we're also going to assume that these two things are mutually exclusive. Like you can't be doing those two things at the same time. So if we look at studying and if we look at hanging out with friends, you got 5 hours with which to do one or the other. Now, we can obviously go to kind of one extreme and say maybe you use all 5 of those hours to study, but then that means you have no hours with which you're going to hang out with your friends. On the other hand, you could spend all of that time hanging out with your friends, but then you have no time studying. But obviously, those are not our only two options that we have. You could split up your time in other ways. Maybe you go ahead and you spend 4 hours studying and 1 hour hanging out with friends, or 3 hours studying and 2 hours hanging out with friends, or 2 and 3, or 1 and 4. And that's just breaking it down by the hour. As you know, we could even go minute by minute as to how you're going to split up your time. But now looking at this, what we can do is kind of look at these different options as points or coordinates on a graph. And what we can do then with those is we can graph them. So let's go ahead and set up a graph here where along our y-axis there we have the amount of time we're going to use studying, along our x-axis there the amount of time we have hanging out with our friends. And using that table off to the left, we can plot those points out. So we have point A would be up there along our y-axis with 5 hours studying and no time hanging out with our friends. And then B, C, D, E, and F. Now, like we had said, those points just represent us breaking it up by the hour. But as you know, we can split up that 5 hours down to the minute or even down to the second if we really wanted to. So therefore, what we're able to do is connect all these points together. And what these points then all tell us is what different options we have with how to split up our time. Now, looking at this a little bit further, let's say that hypothetically you plan your night out as you're kind of coming home from school. You're like, all right, well, I've got some work I got to do tonight, so I'm going to study for 4 hours tonight, and then I'm going to spend that other hour hanging out with my friends. Well, that's represented by point B right there, and we can identify point B on our graph as well. Now, what can be said about your use of time if you're planning on spending 1 hour hanging out with your friends and 4 hours studying? Well, what we can say is that you're using your time efficiently. How can we say that? Well, if you consider studying and hanging out with your friends both as efficient uses of your time, you're utilizing all 5 of those hours, and therefore you're using all your time efficiently. And actually, we can say that any point along that curve is a fully efficient use of our resources. Well, why can we say that? Because any single point along that any point along that line represents 5 hours of either studying or hanging out with our friends. Now, let's suppose that you tell your friends, hey, we're going to hang out for an hour tonight, but your friends tell you, hey, we wanted to go to a movie tonight, and we anticipate that movie is going to be a 3-hour movie. Well, think back to what you had said to yourself. You had said, hey, I've got 4 hours worth of studying to do, but my friends also want me to go to a 3-hour movie. Well, if you notice, that point would be somewhere out here beyond that line that we had drawn. And so what does that exactly mean for you? Well, what it means is that you've got to spend 4 hours studying and 3 hours hanging out with your friends. But can you do that? Well, no, you can't. Why can't you do that? Because like we said, your time is scarce. You only have 5 hours once you get home from school and eat dinner before you're going to bed. Let's say you got that set bedtime. You've only got 5 hours, but you're trying to use 7 hours. So what we can do by looking at our model here is say that any point that falls beyond that curve represents us using more than 5 hours, and therefore any point beyond that curve is impossible or unachievable, because in this case, our time is scarce. We only have 5 hours, and any point beyond that would utilize more than 5 hours. So once again, as we kind of look at this, let's say if you want to go to that movie, let's say that you talk yourself into it and you really want to go to that movie with your friends, what do you got to do? And let's say that staying up for an extra 2 hours is not an option here. You're dealing with only those 5 hours that you got. Well, when you face that decision of hanging out with your friends or studying, you're dealing with a trade-off, because you realize that what you must do, that if you want to spend more time with your friends, you got to spend less time studying. Now, how much less time studying, right? If you want to spend that 3 hours hanging out with your friends, you got to move from point B there, where you're only spending 1 hour with your friends, to point D, where you're spending 3 hours with your friends. But if you notice, since we're moving down along that line, that also means we're going to be giving up some time studying. Now, before we look at this further, I want to come back kind of to a point that we were talking about, the efficiency thing. We're going to be getting into this in a lot more detail later in this course, but it is something I just want to make note of right now. Like we said, any of those 6 options, A, B, C, D, E, or F, or any of those other points, we said it uses all 5 hours of our time. And so we would call any of those points productively efficient, or productive efficiency. Any point along this line, or in this case our production possibilities curve, represents being productively efficient. But are all those points created equal? Right? Like, we don't prefer all those points the same. Like, maybe you prefer to spend a lot more time hanging out with your friends than you actually do studying, but you just know you need to study. So, is there a point that represents the best use of our time? Well, yes, there is. Now, we might not necessarily be able to have enough information here to determine exactly which point that is, but there is some point that represents the best use of our time. And whatever that point is, we call it our allocatively efficient point. It's that single point that provides the greatest amount of benefit. And that point exists where our marginal benefit is equal to our marginal cost. Now, like I said, we'll get into that a little bit later on. But let's suppose that this point of 2 hours studying and 3 hours hanging out with your friends, let's say that was the best use of your time that night. How exactly will we go about finding out that that is? Well, like I said, later on, and especially in 1.6 later in this unit, we'll look at something known as marginal analysis, where we kind of weigh, again, the cost versus the benefit to determine, hey, what point is the best use of my time? All right, back to our situation. So if you do end up going to the movie, how much studying do we have to give up? We said there's a trade-off here. How much time would you have to give up? Well, like we said, you have to go from point B to point D. And this brings us back to that idea we talked about back in 1.1, the idea that, hey, since our time is scarce, it's leading us to have to make decisions. So if you go from point B to point D, you were only anticipating hanging out with your friends for 1 hour. Now you want to hang out with them for 3 hours. What that means is you have to spend 2 more hours hanging out with your friends. Now, if you're going to spend 2 more hours hanging out with your friends, what does that mean on the other end? Well, it means you're going to have to give up 2 hours of studying. So if you don't go up to the movie, you have to give up 2 hours worth of studying. In this case, we would say that the 2 hours of studying that you give up is called your opportunity cost. It's the opportunity that you must give up in order to do something else. Obviously, we know if you go to a movie, there's going to be costs that come where you have to pay for your movie ticket. Maybe you're getting some popcorn, that kind of thing. But here, in economics, we often talk about opportunity costs. We say there's no such thing as a free lunch, right? No matter what, every single decision you make has a cost. And the cost is what you must give up in order to do something. Maybe a little bit more formal of a definition is just the value of your next best alternative. And so, like we said, scarcity leads us to making decisions, but every single decision we make has an opportunity cost. Now, a few more notes on opportunity cost. One thing we do want to make note of is opportunity costs are not necessarily monetary, right? Like maybe you go to that movie and you have to pay for a movie ticket, but keep in mind, you're also giving up the chance to be doing other stuff with your time. You're giving up that chance to study. Or maybe, like I said, we think of opportunity cost. It's what you could have done instead. Maybe you got some money, and let's say you spend $20 on a new shirt, and you're like, yeah, well, the cost of that new shirt was $20. But keep in mind, there is also another cost that comes along with it in a sense. And the cost there is it's the opportunity to purchase maybe a new hat with that $20. So by getting a shirt, you're giving up the opportunity to instead get a hat. Same thing goes with so many other things, right? Like say you go to a restaurant and, you choose to pick one entree off the menu, you choose to get a burger. Well, if you're getting a burger, you're giving up the opportunity to instead get chicken tenders or something like that. One other note about this is opportunity cost is just the value of your next best alternative, not all your other alternatives. So opportunity cost is not every other alternative, just the one that would have provided you with the next most satisfaction. So back to that example of, buying the shirt. If I buy the shirt, my opportunity cost is not everything else I could have done with that $20. It's just what I could have done, what would have provided me with the next best use of that money. Maybe that hat would have been the next best use of my money. It's not everything else I could have bought using $20. Or another example, back to that, going to a restaurant, right? When you choose the burger, it's not the burger versus every other entree. It's the burger versus just whatever entree you would have gotten instead. Or as you're looking to go to college, it's not when you pick a university and you choose to go to University A, it's not you're giving up every other university. It's just the one other one you would have attended instead. So opportunity cost, you can think of it as the opportunity lost or the opportunity that you forego. So let's go ahead and take this example up to looking at like an entire country. Let's suppose we have a country by the name of Bradley Land, and it uses its productive resources to produce one of two items. Let's say they're producing cars and they are producing boats. Now, they have a set amount of resources that they're working with to either produce cars and boats. And let's say we have this table here that shows us the different combinations of utilizing those resources to produce either cars or boats. So for example, what this shows us is that they're at point A. If Bradley Land used all of their resources to only produce cars, they could produce, say, 60 cars in a day, but then they're not producing any boats. On the other hand, they could be over there at point G where they're producing 36 boats using all of their resources, but then they don't have any resources left over to produce any cars. Now, again, those aren't their only two options. They have other options in between. They could split their resources up throughout the day and maybe, like point D, they could produce 30 cars and 18 boats or something like that. But similar to how we did with our time, either studying or hanging out with friends, we can use these points to plot out our different possible options of how we can use our resources in order to produce cars and boats. So again, we can plot point A, B, C, D, E, F, and G. But again, like we said, these aren't our only 7 points that we can be producing at. We could do other combinations. We have other, more smaller increment changes that we could have. And so therefore we connect all of these points together because then all of these points together will give us our first kind of main piece of this model, which is known as our production possibilities curve. A production possibilities curve is a curve that shows us all the different possible production points given a set amount of resources. So this line here, this curve here shows us, given the amount of resources available to Bradley Land, what different possible production points do they have? Which different combinations of those resources result in different outcomes of numbers of cars and boats? Now, as we work with our production possibilities curve throughout this course, we're going to be playing under a few assumptions. The first assumption we need to realize is that any of these points along our production possibilities curve, they're only achievable if a country achieves full employment and full efficiency. So here's what that means is that we have all these resources available to us. We're going to assume that along that line, we're using all of those resources to the best of our ability. We're utilizing all of our labor. We're utilizing all of our factories and machines and things like that. Second, we're going to assume that resources are fixed in both quantity and quality, right? That we only have a certain amount of resources available to us, or that we only have a certain quality of those resources available to us as well. Now, finally, the last thing is that this is going to represent just one country that is closed off to trade. So as we start looking at our production possibilities curve, we're going to assume that in this case, Bradley Land is closed off to trade. They don't have the option to trade and get cars and boats from any other country. They're just working within their own country. So again, in producing cars and boats, what we would say is that any of these points along our production possibilities curve is attainable, and not only is it attainable, it's also desirable. And we know it's desirable because we're being fully efficient with our resources. It represents us using all of those resources to the best of our ability. Similar to the use of our time, though, we said any point that falls outside of our production possibilities curve, any of those points there, we would say it's unattainable, because any point or any combination of cars and boats that falls beyond that line, our resources are too scarce. We don't have enough resources to produce at one of those points outside of our production possibilities curve. Now, what about points that fall inside our production possibilities curve? Well, here's the thing about this. Yeah, we could produce those combinations, say 12 cars and 12 boats. We've got the resources to do that. However, what we see is that while it's attainable, it's undesirable, because what that means is we are not being fully efficient with our resources. Maybe it represents unemployment, where we're not utilizing all of our labor. Maybe we have factories sitting idle. We're not utilizing all of those resources. So again, while it is possible, it's inefficient. We had mentioned that we can use this model in order to find opportunity cost, looking at these trade-offs that might be made. So let's do that for the country of Bradley Land here as they consider producing either cars or boats. So what we have here is 5 different questions that are like questions that you might see with regards to opportunity cost when considering producing either cars or boats. So take a second, pause the video, and see if you can't work through these 5 problems. All right, so let's look at this first one. What is Bradley Land's opportunity cost for producing 6 boats? So if they want to produce 6 boats, and so this is just saying that at whatever point they're at, they just want to start producing 6 more boats. Let's suppose, let's just pick a point. Let's say they're at point A. And let's say from point A, they want to move their production of boats from 0 up to 6. Now, in order to do that, like we said, there's a trade-off. If they want to start making more boats, they got to make fewer cars. They have to shift those resources away from cars and toward boats. Well, how many cars would they have to give up? Well, if you notice, in going from zero boats up to 6 boats, our car production would drop from 60 cars down to 50 cars, which means that our opportunity cost for producing 6 more boats would be 10 cars. Or we're giving up the opportunity to be producing those 10 cars, from 50 to 60, by producing 6 more boats. What is Bradley Land's opportunity cost for moving production from point E to point B? So let's assume that we're at point E, where we're producing 20 cars and 24 boats, but we want to shift our production up to point B, where we're producing more cars. So in fact, we want to start producing 30 more cars going from E to B, but in order to do so, we have to stop producing some boats. Well, if you notice, our boat production at point E is 24. By moving to point B, our boat production would drop to 6. So how many boats would we have to stop producing? Well, 24 minus 6 would be 18 boats. What is Bradley Land's opportunity cost for moving production from, what's opportunity cost for producing 5 more cars? So Bradley Land just wants to start, again, at any point producing 5 more cars. Again, let's assume maybe that we're over there at point G and they want to move their production from 0 up to 5. So we're not moving all the way to point F, we're just moving halfway toward point F. Well, in the same way, going from 36 boats there, we're going to go halfway toward 30 boats at point F. So we're not going from 36 all the way down to 30. We're just going from 36 to 33. So in going from 36 down to 33, our opportunity cost is 3 boats, because in moving production from 0 cars up to 5 cars, our boat production would drop from 36 down to 33, which means we're giving up 3 boats. Now, these last 2 are very similar to ones that you might see, especially as we move into comparative advantage in 1.4. What is Bradley Land's opportunity cost from producing just 1 more boat? So we're not asking for all 36, we're not asking for 6, we're just asking for 1. Well, really the easiest way to do this, in my opinion, is to start by looking at our 2 extremes. We could be using all of our resources to produce 60 cars and 0 boats, or all of our resources to produce 36 boats and 0 cars. So those resources can produce either 60 cars or 36 boats. So what we can do is we can say that 60 cars is equivalent to 36 boats in production. Or if we want to start producing all 36 boats, we have to stop producing all 60 of those cars. Now, we're not asking about producing all 36 boats. We're just asking about producing one more boat. So what we can just do is if we set those equivalent, like set 60 cars equivalent to 36 boats, and we want that 36 boat side to just say one boat, we can divide both sides by 36. 36 over 36 gets us 1. 60 divided by 36 gets us 5/3 or 1 2/3 cars. So for every one boat we want to start producing, we have to stop producing 1 2/3 cars or 5/3 cars. What is Bradley Land's opportunity cost for producing one more car? Well, we could do the same thing again, set those 60 cars equivalent to 36 boats in production, but this time we want to know the opportunity cost just for one more car. Well, if we want to know just for one more car, we'd actually divide both sides here by 60, because dividing 60 cars by 60 would get us just one car. That would, on the other side, give us 36 divided by 60, and 36 divided by 60 gives us 3/5 of a boat, or 0.6 of a boat. Now, if you notice in those last two, those numbers are just reciprocals, and so that'll be true every time. In every example we've looked at so far, where we've looked at our time or we've looked at the production that we've had for cars and boats, what we've seen is that our production possibilities curve has been linear. It's been a straight line. This is actually something that is known as constant opportunity cost. If you notice with our time, 1 hour of studying is the same as 1 hour of hanging out with friends. Like they're both 1 hour, 60 minutes. Or if you notice the trade-off, every single time we wanted to add one car was the same as one boat. And so what we see when we have a constant opportunity cost, our production possibilities curve is linear. And since the slope represents our opportunity cost, the rise over the run, the trade-off from one versus the other, that's why it's constant, because we have a linear production possibilities curve. So as you add 1 unit of good Y, you must always give up the same amount of good X. Now, this is because we assume that the resources are adaptable from one product to the other. And what that means is when we shift resources from one to the other, we assume that it's kind of like this smooth transition, and it's always that same transition from one to the other. Like we said, with time, 1 hour of studying, 1 hour with friends, they're both 60 minutes. Cars and boats, they use fairly similar tools, parts, things like that in order to produce one versus the other. So the resources are fairly adaptable to one another. However, sometimes we'll see a production possibilities curve that has a little bit more bowed out of a curve. And we actually say that this is an increasing opportunity cost. And we say this is increasing because if you notice that slope is actually increasing as you move from left to right along the curve. And so again, it's curved outward. Slope is increasing as you go, or really you could say like the absolute value of the slope technically is increasing. But what we see here is that as you add 1 unit of Y, you must always give up more of good X. Every time you're adding an additional Y, you're giving up more and more of X. And this is typically because the resources are not super adaptable. Maybe it has to do with the fact that the skills needed to produce one versus the other are different. And so as you shift workers from one to the other, you're going to be shifting your, like, first when you move workers away from X toward Y, you're going to shift over the workers that are really, really bad at making X and relatively okay at making Y. And so therefore, you're not losing out on much of X. But as you send more and more workers to produce more and more of Y, you're giving up workers that were better suited for good X. And so resources are not as adaptable from one to the other, and therefore our opportunity cost increases as we go. The final example is decreasing opportunity cost, where you see it's the slope is actually decreasing as we go. Now, one thing I just want you to know, what we see here, as you add 1 unit of Y, you must always give up less of good X. We're really not going to see examples of this throughout this course. It is possible, but it's very rare, and therefore I'm actually not going to give much time to it at all. last things wrapping up here with production possibilities curve. Like we said, the production possibilities curve does teach us quite a bit. It teaches us about this idea of scarcity, right? Like the idea of different locations along the model show us that, hey, because our resources are scarce, we can only be at certain points. We can only reach certain combinations, either along our line or inside of our line, right? It teaches about opportunity cost. Moving from one point to another, if we want to get more of one thing, we have to give up some of the other, right? If we want to produce more of good X, we have to give up some of Y. And whatever we have to give up of Y, that's our opportunity cost. It also teaches us about efficiency because, we said any point along that line, that's us using all of our resources as efficiently as possible. Or any point inside of that curve, being inefficient. We're not utilizing all of our resources to the best of our ability. And so it teaches about inefficiency as well. Like we said, those point inside, they're attainable. They're just not utilizing all of our resources well. And last thing, let's talk about growth. Because we said that, hey, we're going to assume that for the time being, our resources are fixed in quantity and quality, but that's not always true over time, right? Like we see that can change over time. Economic growth occurs when the amount of goods or services a country can produce, it can increase. And we see that happens with countries. You look at the United States, like the amount of goods that the United States economy is able to produce now is greater than what it could produce 100 years ago. So we've experienced growth over time. Now, what is it that causes growth? Well, first of all, when we see it on our model, it looks like a shift outward of our production possibilities curve, where some of those points that were once impossible now become possible. But what might cause this growth to occur? Well, I think some of these might make a lot of sense to you. First of all, an increase in the quantity of our resources. If we have more workers, if we have more machines, we have more factories, well, that's going to allow us to produce more of our goods. Maybe it's an increase in technology. That's been one of the keys to growth over the last 100 years or so, is that as we've acquired more and better technology, it's allowed us to produce more efficiently. And finally, increase productivity. As we're able to be more productive, maybe thanks to an increase in technology, or maybe thanks to training of our workers or fine-tuning our machines, it allows us to be more productive. And so what we actually end up seeing is that economic growth is constantly kind of occurring in the world that we see today. But we also see that depending on where our starting point is, it can affect future growth. Like if we were to say focus more on capital goods now, right? Those goods that we use to produce other goods and services. So if we're spending more time making those now, it's going to allow us to have more capital goods in the future, which allows us to make more of everything else in the future, right? If we're focusing maybe instead more on consumer goods now, things that consumers are having and utilizing now, well, we're not expanding our production capabilities necessarily as much. And so maybe it won't allow us to grow as much as before. And so, looking at these different points, a point like point D might allow us to achieve more future growth, right? Because by focusing more right now on capital goods, we're able to produce more stuff in the future. If we instead maybe chose point A, we might not have as much growth in the future because we're not focusing as much on those capital goods. We're focusing more on consumer goods. And since we're not focusing on capital goods as much, we might not have as many factories, machineries, or whatever it might be in the future for future production. So the production possibilities curve is an incredibly helpful model, shows us and teaches us so much about different scenarios. And we'll be looking at variations of this as we continue throughout this course.